You know, for literally all of human history, every single person who's ever looked up at the sky has seen the exact same face of the moon. But what about the other half, that hidden side, the so-called dark side? It's been this place of pure myth and mystery for, well, forever. So today, let's pull back that cosmic curtain and see what's really hiding back there.
It's the kind of question that just gets your imagination going, right? But first, let's get one thing straight. It's not actually dark. It gets just as much sunlight as a side we see. So the real mystery isn't about a lack of light. It's about why we can never ever see it from Earth.
Okay, so the reason is this really cool cosmic dance called tidal locking. The best way to picture it is imagine a dancer spinning around a partner. She's rotating, but just at the perfect speed so that she's always facing her partner no matter where she is in the circle. Well, that's exactly what the moon does with Earth. It completes one full spin on its axis in the exact same amount of time it takes to do one full orbit around us. Pretty cool, huh? And because of this perfect lockstep for thousands of years, the far side was just a complete unknown, a total blank spot on our map of the cosmos. And you know what happens when there's a void like that, right? It becomes the perfect canvas for our imagination to run wild. Seriously, people imagined everything back there. Hidden alien bases, strange, impossible landscapes, you name it. It was this ultimate frontier, not just in space, but a frontier in our own minds. But then, everything changed. The space age arrived. And for the very first time, we had the technology to finally peek behind that curtain. So let's just run through this incredible timeline, because it's a great story. It all kicked off back in 1959. The Soviet Luna 3 probe snapped the very first kind of grainy, ghostly images. Then, a huge leap forward in '68, the Apollo 8 astronauts became the first people to ever lay eyes on it directly. Wow. And then, a really big deal in 2019. China's Chang'e 4 pulled off the first ever soft landing on the far side. And the story's not over, not by a long shot. We've got NASA's Artemis II mission coming up. And the amazing thing is, when those first pictures from Luna 3 finally came back to Earth, they were a total shock. Scientists were basically expecting to see, well, more of the same moon. But no, the far side looked nothing like the familiar face we see every night. So the mystery wasn't solved, it actually got a whole lot bigger.
Yeah, this wasn't just a few small differences. Scientists quickly realized the moon basically has a split personality. It's a true tale of two sides, two completely different worlds.
This chart here does a great job of breaking it down. So the near side, our side, is covered with those big, dark, smooth patches we call Maria. But flip it over, and the far side is a totally different beast. It's rugged, it's absolutely packed with craters, just highlands as far as the eye can see. And look at these other key differences. The crust is way thicker on the far side, and it had almost zero volcanic activity, which is what created all those smooth plains on our side.
So, you gotta ask, why? Why is it so different? Well, the leading theory is all about that crust. The crust on the far side is just thicker, a lot thicker. You can think of it like a massive geological shield that stopped magma from bubbling up to the surface. No magma, no lava flows, and no big, dark volcanic plains.
But here's where it gets really interesting for scientists today. The far side isn't just a geological puzzle. Its most important feature might actually be what isn't there, and that creates an absolutely incredible opportunity for science.
Think about it. The entire massive body of the moon itself acts like a giant natural shield. It completely blocks out the non-stop storm of radio waves, TV signals, Wi-Fi, all the electronic chatter we blast out from Earth 24/7. This makes it, literally, the quietest place anywhere near us in the cosmos.
For a radio astronomer, this place is the Holy Grail. Just imagine building a telescope there. You could listen for the absolute faintest whispers from the very dawn of the universe, signals that are totally drowned out by all our noise here on Earth. Now, there is one big catch, of course. You can't just call home. The moon's in the way. So you need a relay satellite, which is a major challenge that, by the way, missions like Chang'e 4 have already figured out.
And that incredible scientific potential, it's a massive reason why we're so focused on going back to the moon. Which brings us right up to today and the Artemis program. This is the next big chapter in our story with the moon.
So the very next major step is Artemis II. And this is a huge deal. For the first time in more than 50 years, we're going to have astronauts traveling way out beyond low Earth orbit. They're going to fly all the way around the moon and see that far side for themselves.
The whole Artemis plan is really broken down into 3 big steps. First up, you've got step 1, which is Artemis II. That's the all-important test flight, to make sure all the life support and communication systems are working perfectly. Once that's done, it's on to step 2, Artemis III. And that's the one where we put boots back on the moon. And then comes the grand finale, step 3, setting up a permanent, sustainable presence there. The idea is to use the moon as a stepping stone to explore the rest of the solar system.
So when you boil it all down, Artemis II is about one thing: proving we can safely send people out into deep space again. And while they're out there, that crew is going to get some unbelievable new observations and data on the far side. That information is going to be absolutely crucial for planning where to put future bases and science outposts. So yeah, it's way more than just a test flight. It's really the bridge to everything that comes next.
It's pretty amazing when you think about it. The far side has gone from being this complete mystery to a priceless scientific sanctuary, and now a potential staging ground for exploring the cosmos. It's come a long, long way. Which leaves us with one last, really exciting question to chew on. As we start to look out from this quiet, hidden side of the moon, could it really become our gateway to the stars?